All right, today we continue our discussion on summarizing data and creating data displays. Today specifically, we will be talking about different types of data to create, a lot of which you've probably already heard of before, and then we'll review box and whisker plots and how those are created and how those are interpreted. So here are some data summaries, again, a lot of which, if not all of which, you have heard of before. We have finding the mean, which is just another name for average, adding all the data points and dividing by the number of data points that you collected, or dividing by the sample. A mode is a data point that repeats the most. Maximum is the highest, minimum is the lowest, and then the range is the difference between the two. And a big one that we'll talk about today is the median. Okay, it says the median is a midpoint of a distribution. We've already talked about that back in just back in that last video. And so to find the median, you have to arrange the numbers from least to greatest. If there is an odd number of data, the median is in the center. If there's an even number of data, then you'll get two numbers in the center, and you find the mean of those two numbers. Okay. And again, I kind of showed you that process doing it by hand. Today what I'm going to do is I'm going to show you how to do that process on your calculator so that we don't have to go back and forth and make that really tedious. Okay, we're going to let the technology do the work for us. Furthermore, again, just lots of different ways to describe data is breaking it into quartiles, breaking it into groups of 4, in other words, right? Quarter as 4. There's 4 quarts in a gallon type of thing. So when numbers are ordered from least to greatest, the first quartile is the median of the numbers to the left of the overall median. So it's the median of the median, in other words. But so is the third quartile. The third quartile is also the median of the median. And so the first quartile, also known as Q1, also known as the lower quartile, is the median of the numbers to the left, or of the lower numbers. The third quartile is the median of the median to the numbers to the right, also known as the upper quartile, so the numbers that are above it. Okay, so there are kind of 3 different ways that you can represent, or you can name the different quartiles. First quartile, third quartile, lower quartile, upper quartile. And if you're wondering, what about Q2? That's what we call the median, is Q2. Okay, and then we also look at the interquartile range, the IQR, where we take, just like the range, we do the upper quartile minus the lower quartile, okay, to get the interquartile range. And what we'll do today is we'll talk about why some of these things might be helpful. So when you're making a box and whisker plot, you create that making what's called the 5-number summary, or finding the 5-number summary. The minimum Q1, median Q3, and maximum value. Again, the median is known as Q2. So if you're wondering where that is, it's because that's another name for the median. And when you're making a box and whisker plot, what you typically do is you put lines where the medians are, and then create a box with those lines. And then the minimum and maximum values are the whiskers. So you put a point wherever the min and max are, and that is how you get your box and whisker plot. And that is why it is called the box and whisker plot, because it is quite literally a box with what looks to appear to be whiskers. So when you're making a box plot, graph the 5-number summary just like we did. A line through the box marks that the median and the quartiles, and then lines extend from the minimum and maximum values. Okay. Outliers. We talked briefly or mentioned outliers in the last video, and there is an actual way to calculate outliers. An outlier is any number that is more than 1.5 times the interquartile range, the IQR. Okay, so to find any outliers that are above the data set, that are above Q3, you would do the third quartile plus 1.5 times the interquartile range, or if it's below, then it's Q1 minus 1.5 times the interquartile range. Okay, We'll practice how to find and identify outliers, and we'll also look at how we treat them differently on box and whisker plots when we are graphing. Okay, so throughout this example, you might find it helpful to pause because I already have some of this set up on my calculator, so I'm not wasting video minutes setting things up. Okay, and so what you need to do is you grab your graphing calculator and hit the stat button on your calculator. Hit stat. And that first option there, go ahead and hit enter. And clear out whatever is in there. So if I had a bunch of stuff in L2, all right, and I wanted to clear out those numbers, you can delete every single one, or just go up to L2, hit clear, hit enter, and the whole thing's gone. Okay, so if I wanted to clear L1, I don't want to because that's my data set, I would scroll up to L1, hit clear, hit enter, and all of those numbers would disappear. Okay, so clear anything out that you need, and then go ahead and hit pause and enter in all of these numbers into L1. Okay, so again, I'm going to keep going, so go ahead and hit pause and then hit play when you're ready to go. Once you have those numbers entered, hit stat, go over to the calc menu, and it's this first option. What this means is one variable stats. Okay, if you hit enter, all right, make sure it says L1 right there. If it doesn't, hit second and the 1 button. See how it says L1 in blue there? To make it say L1. Don't worry about that frequency list. And then go ahead and hit calculate. Okay. So here is a bunch of information about the data set that we entered. Okay. Let's see if I can do double duty here. Okay, I'll kind of make this work. So the first number that we are looking for is the mean. A symbol for mean in math is it's called X bar, X with a bar on top of it. And so that first number that you see, 27.48, is the mean of our data set. Okay. Mode is the number of times the data repeats, and if you scroll through, you cannot find the mode, so that is one thing we will need to do by hand. And so let's just take a quick look here. I see 8 twice, I see 3 twice, I see 0 twice. Is there any number that's 3 times? And by not putting this in numerical order, I'm making this a little bit more challenging for myself. I also see 1 twice. Oh, I see 8. Nope, just twice still. So it looks like there's a few numbers that repeat twice. 0, 1, 8, and 3. And so those are all my modes. 0, 1, 3, and 8. So you can have no modes, or you could have multiple modes, or, oh, I just noticed 25 repeats twice, so that's another mode in this case. But you could have multiple modes, as you see in this example, or you could have no modes. Okay? Any number that repeats the most number of times is a mode. And so in this case, there are multiple numbers that repeat twice, and so I have all of those modes. Okay? And then the range. The range is the max minus the min. So it looks like my biggest value is 118. My smallest value is 0. So the range of my data set is 118. 118. Okay. Find the numbers, 5-number summary. Here's where our calculator comes into play. It's done it for us. Okay, it even did the min and max if you didn't want to try to find that. All right, your min is 0. Your Q1 is 3. Come on, move. There we go. Q1 is 3. Your median is 9. Your Q3 is 43. And then your minimum value, or sorry, your maximum value is 118. And now that I have moved my eyesight down lower, I realize I have them all in order there. And did I miss a third 0? I did miss a third 0. How about that? All right, so the only mode for this data set is 0. because there's 3 zeros, and then 2, 2, 1, 2, 1, 1, 1, 2. All right, so I apologize for that mistake. The only mode for this data set is, in fact, 0, because there are 3. And now that I'm looking, I see all 3 there. Okay. Now, again, it was good to at least know or make a note of that there can be multiple modes, but that was my mistake. There is only 1 in this case because 3 or 0 repeats 3 times. Now, what your calculator does not do is IQR and outliers. Okay, and so let's practice how we find IQR and outliers. And so again, IQR is Q3 minus Q1. And so in this case, 43 minus 3 is 40. Okay? And to find your outliers, again, it's Q3, so 43, plus 1.5 times the IQR. Okay, and so 1.5 times 40, 1.5 times 40 is 60. And so what this means is that anything above 103, all right? So in other words, 118 is considered an outlier. Okay? To find the other side of the outliers, it is Q1 minus 1.5 times 40. So Q1 was what, 3, and then minus 60. In this case, we are talking about sending text messages, so we can't even get negative 57 text messages sent. And so there is no lower outlier, but the only outlier is 118. And so what you do with outliers on a box and whisker plot is you actually change it so that the max of the box and whisker plot is now 98. This is your new maximum value. Okay? And so if I were to sketch what that might look like, and I'm not going to be super perfect here, but your minimum value is at 0. Okay? Then we have Q1 is at 3. All right, the median is right not too far away from that at 9, so that's median or Q2. And then your Q3 is quite a bit of ways at 43. Your max is even further away from that at 98. Oops, at 98. And then what you would do with the outlier is you would still plot it, but as a separate point from the data set. And so that would tell somebody looking at your data that 118 is an outlier. Okay? So that's how outliers change data sets. All right, everything else stays the same. So you don't recalculate the you don't recalculate the quartiles or anything like that. You keep 118 in the data set, but you do change the max to 98, and then you leave 118 as an outlier. Okay, so that's how outliers are calculated right here. And then that is, graphically, that's how they are represented on a box and whisker plot. Okay. If you were calculating the average of this data set, here's why when you are looking at, your teacher enters in a test score and you want to know what the class average is. Here's an exact reason why the class average is not actually a good number to look at. All right, let's go to our data set here. Okay, right now the average, we wrote it down, is 27.48 text messages sent. Let me go back into my data set. So let me find 118. There it is. And let's delete it from this data set. Okay, boom, gone. All right, let's see, boom, calc, one variable stats. My average text messages just dropped by 4 text messages, okay? And we're talking text message, you might think, well, that doesn't seem like a lot. But let's just say it was points on a test. Okay, 4 points on a test is a pretty big difference. And by taking out one outlier, that changed the whole thing. And so again, that's why we cannot. Average is an okay number to use, but the average of something doesn't tell the whole story. Okay, because of outliers, the average, and that works on the other side too. If we have a couple people do really poorly on a test, that's going to bring down the average. And then some of us look at that and say, oh, the average was that low. Obviously it wasn't a very fair test. Well, what if 3 kids are bringing down that average? So average is a good statistic, but it never tells the whole story. And that's one thing to know about all statistics. Every statistic there's not a single statistic that tells the whole story of anything. Okay, that includes average. All right. There's my rant for the day. Let's keep talking about box and whisker plots. So again, quartiles break up the data into 25% chunks. All right, and so the quite literally, each quartile represents 25% of the data. All right, and so if you picture it again, just sketch one here. Got to get the sound effects. All right. This chunk is 25%, this chunk is 25, that chunk is 25, and this chunk is 25. Okay? So when we are looking at what percentage of the data is within the IQR, well, the IQR represents two 25% chunks, and so 50% of the data is within the IQR. What percent of the data is above Q1? Okay, well, Q1 is that left bar. Above Q1 represents 3 25% chunks, so 75% of the data is above Q1. Okay? When we compare the data sets below, this is really what box and whisker plots are best used for, is comparing data sets. Okay? Looks like we have bone density measurement in males versus females, and we can make some generalizations here. It looks like females have a wider range of results. Okay? Notice how spread out the box and whisker plot is. Not only from min to max, but from Q1 to Q3. Okay, that box is more spread out. It looks like men, again, summarizing, have higher bone density than women do. Okay. In fact, notice that the min for the max, or the minimum for the male, is at the first quartile for females. And so again, this is why the purpose of box plots is really to compare data. It's not just, it's fine to organize one data set into a box plot, but again, it's most useful when you're comparing two different box plots. Okay. So 3.9 and 3.10 was about box plots. You had just previously finished using Google for a lot of different things. We are just getting ready to finish up chapter 3. It looks like we have maybe one more video after this, and we will get into one more way to measure data.